In this video, we're going to learn about some of the most important measures for evaluating the performance of classification models. We're going to look at precision and recall, specificity, and sensitivity, which come in pairs. We're going to understand intuitively what they are, what they mean, and learn a few tricks to remember which is which. So there are many, many kinds of measures for evaluating the performance of classification in machine learning. And here's a link that can summarize some of them, a lot of the most important ones. And I have to be honest that there's a lot of subjectivity in that different people have different preferences on what they like. And so my perspective are the ones that I think are most useful for managerial decision making, that are most easily interpretable or transferable into managerial decisions. So first, there are two pairs. There's precision and recall, and there's sensitivity and specificity, which focus on specific managerial priorities. That's we're going to see. Then another very useful approach is the ROC AUC, that's receiver operating characteristics area under the curve, which is a holistic comparison of model classification performance. So it's one number that really looks at a lot of things at once. Then another approach is lift curves, which is a graphical way to segment and prioritize the segments of cases with the highest return on investment. Now, personally, I really try to avoid single measures. There's a lot of measures such as accuracy, F1, the G-mean, kappa, etc., that try to look at all different aspects and put them into one number. And these are almost all based on a very fundamental flaw, which is that they wrongly assume that correct and incorrect responses are equally valuable. And so they try to get a balanced weight. And almost always, a manager cares more for correct classification or more for incorrect classification. That cares more for positive or for negative cases. There's really a lot of managerial discretion on what is more important or what is equally important. And so grouping everything, lumping everything to one number really loses a lot of that important intuition. A notable exception is AUC, area under the curve. In other videos, we'll see how that can be quite helpful when used cautiously, not as a number that tells you what to do, but actually that becomes a base from which to deviate for according to managerial priorities. So the point here is that we need to focus on the measures of classification quality or performance that really emphasize what is important in a particular organizational situation. So to understand the measures that we look at, it's important to understand the classification matrix, also called a confusion matrix. And the first thing to understand is what is a positive or negative class, what exactly that means. Positive means what we are looking for, and it might be desirable or undesirable. So in our modeling, some desirable examples, we might be looking at which customers will purchase or not. Those who purchase, that's a positive case. Which projects will succeed or not. Those who succeed are the positive case. Does the medicine work or not? And when it works, that's a positive case. Undesirable examples, which is that this is what our model is looking for. We might be looking for when does disease occur. So when we find a disease, that is the positive case. We might be looking at a set of customers that are our subscribers, and we're trying to find out which ones are about to cancel the contract. those who cancel are the positive case because that's what we're looking for. Maybe we're studying machines and looking at when do they fail or not. Well, when a machine fails, that is the positive case. So positive and negative do not mean positive in the sense that it's something that makes us happy, or negative is something that makes us sad. Positive is what we are looking for, and negative is what we are not necessarily looking for. Now, when data is imbalanced, and by that I mean that it's not a 50-50 split. So it's not like 50% of customers buy, 50% don't. Maybe it's only 10% buy and 9% don't. Well, whenever data is imbalanced in that way, the minority class, the smaller class, is usually the positive one. And that's because the majority is a default. So if you're looking at diseases, well, most people don't have the disease. And so the exception is those who do, even if it's only 2%, that's what you're interested in. If you have, maybe you have an offer and 80% of your customers say yes normally, well, in that case, you're more interested in the 20% that don't say yes. So why not? And that becomes your positive class in your analysis. For multi-class scenarios, that's when you have more than just two classes, yes or no, maybe classes A, B, and C. Then the positive class becomes a class of the greatest interest. Of all the different groups, categories, which one are you most interested in? So, for example, if you're studying whether a certain medicine works, and the possible outcomes are the medicine works, or the medicine there's no difference. The patient doesn't change, or the medicine actually hurts the patient. They actually get worse. Well, those are three classes. Well, in these cases, you're most interested in does the medicine work or not. So that does medicine work is your positive class. And you could group the other no different or worsened condition into one class, which becomes it does not work. Now, you could a lot of techniques could let you classify the three classes separately, but there are reasons to group all the things that are not positive into one negative class. Managerially, sometimes it's just more important than anything else. So, like in the medicine example, maybe as the doctors want to know does the medicine work or not, and well, whether it doesn't work or the patient gets worse, well, even without the medicine they might not have gotten worse, so just lump into it the medicine did not help them get better. You're really interested in focusing on whether the medicine works or not. Then technically, that is the actual analysis of models. Sometimes, well, a lot of techniques work and classification measures work specifically for binary classification. That's when you have two classes and they don't work without significant adjustment for multiple classes. And to use these techniques, a lot of time you'll just use, you might lump everything that's not positive into negative classes. Okay, so now that we understand what positive and negative classes are, let's look at these two pairs of specific measures. First, precision and recall. What I have here is a classification matrix where on in the columns are the results when of what actually happened in real life. That is, they're either real negatives, that the cases are negative. Let's use customers as an example. The customers did not buy. And in real positives, the customers did buy. But then on the rows are what the models predicted. And did the model predict negative, that did it predict they did not buy? Did it predict positive, that they did buy? And in this case, so based on that, when they predict negative, but it is negative, it's a true negative. When they predict positive and it is positive, it's a true positive. But when the model predicts negative, but actually it's a positive, then it's a false negative. And when the model predicts positive, but actually it's a negative, then it's a false positive. So based on this, we have the different measures of how well the model did. Accuracy is the simplest one, looking at true negatives plus true positives. So all the correct all the correct predictions divided by all the predictions. Now, precision and recall focus on the proportion of the true positive results. That's what proportion did the model correctly predict. So both of them focus on this. Precision is calculated as the true positives divided by true positives plus false positives. So that is true positives divided by all the predicted positives. So the model, out of everything the model predicted was positive, what proportion were actually true? And that is precision. Recall, again, focuses on true positives, but instead it looks at what was actual truly positive, and out of all those that were truly positive or really actually positive, what proportion did the model correctly predict? So it's a proportion of real or actual positives that were actually correct. So again, precision and recall both focus on true positives in the numerator. But to remember which is which, precision, contain PRE, is TP, true positive, divided by predicted positives. They have PRE, precision, PRE, predicted. Recall is true positives divided by the real positives. So that's true positives divided by the real positives. Recall has REA and real positives has REA. So with that, you can distinguish those two. Sensitivity and specificity are another pair. And the focus here is looking at among those that are real or actual positives and among those that are real or actual negatives, what is a proportion of correct predictions that a model made based on compared to reality. Sensitivity looks at true positives out of all the real or actual positives. So out of what actually was positive, what proportion did the model correctly predict? And so that's true positive over real positives. Now you might note that the formula for sensitivity happens to be exactly the same as for recall. They are just two different perspectives of looking at exactly the same thing. Specificity, however, is different from the other measures. It looks at the true negatives and looks at what proportion of all the actual real negatives were correctly identified. So that is the proportion of actual negatives, uh, so of of true negatives that were correctly predicted. So to remember which is which, it's a little bit counterintuitive because the p's and the n's are swapped. And so to remember them, I use the mnemonics SNP and SPIN. SNP for sensitivity is positive, so SN, which means that sensitivity has true positives on top and focuses on real positives under. And SPIN, specificity, is negative, which means that specificity focuses on true negatives on top and real negatives below. So I use that to distinguish these measures. So in another video, we're going to continue this topic and try to understand which of these, precision and recall, or sensitivity and specificity, would you want to use in which kinds of scenarios.